So first, thank you very much for giving me the opportunity of presenting our work here that we do in TVB-Cloud. My name is André Gemünd, and a little bit of background. So as was introduced already, I'm working for the Fraunhofer Scientific Computing and Algorithms Institute, and our department focuses on distributed infrastructure projects, mostly HPC, high performance computing, cloud, and big data infrastructure, for example. And we usually deal with cross-cutting topics like scale-out, authentication and authorization infrastructure, automation, issues of information security, and so on. We are also active in research projects on European and national level, and there are some examples on this. Notably, for example, Cloud for Health, one prior project in the medical area. So what is TVB-Cloud? That has already been introduced just shortly. The project is developing a cloud-based platform for personalized prevention and treatment of neurodegenerative medicine and the integration of multimodal data. And when we're talking about the concept of TVB-Cloud, we're talking about a platform that integrates a lot of components into a collaboration portal accessible by end users and an underlying cloud-based, secure, and trusted IT infrastructure. We from Sky, we are leading the work package that is about implementing the secure cloud-based infrastructure. So how does that look like? Well, it ensures information security and data protection based on principles like confidentiality, integrity, availability, transparency, intervenability, and unlinkability. And to make those principles tangible, it's required to have organizational and technical security measures, which are usually embedded in a concept, in an information security management system. And the sole implementation of one of these is hopeless and not effective. You need to deal on all of these levels at the same time. And there are many well-known approaches on how to implement such systems. For example, the ISO standard on information security management systems. In TVB-Cloud, we compose a set of technical security measures on different levels that are involved. And we primarily drew upon experience we gained in prior projects, guidelines that were proposed by the German Federal Office for Information Security, BSI, and the fantastic support by our colleagues from the University of Vienna. So considering that we are already at an advanced point in time on Friday afternoon, we thought we'd approach this in a little bit of a different manner, hopefully also with a little bit of entertainment. And we want to present challenges putting data protection into practice, and especially 10 gaps between theory and practice. A little bit how we, well, the things we met when implementing in TVB-Cloud until now. So in theory, we should be easily able to decide if data is personal, right? Well, that's what we thought. That's not clear at all. I mean, there have been multiple examples today already. And for example, we had this, I think, derived data from machine learning models. Do they count as personal data or not? It's not always clear. Often it's completely unclear. And there are even differing opinions among scientists about this. And there's also the factor of changing state of science and technology. So what's known today is not necessarily true tomorrow. What's the consequence of that? Well, there's a lack of a decision basis. We don't know how we need to act based on that. And changing requirements obviously complicates the development of the platform and the infrastructure in the project. And the worst case being that the changing requirements lead to a uselessness of the infrastructure solutions. They are not fit to what we need anymore. A second one, data protection officers are easily able to assess if data is appropriately protected while it's being transferred, processed, and stored on external infrastructure, right? That's the theory in GDPR at least. Well, in practice, only few DPOs are really also IT infrastructure and cloud experts. And this this is not in any way meant negatively on DPOs. It's just, if you have ever tried explaining your parents that you're working on a microservice architecture hosted on a Kubernetes cluster running in the cloud, then you should know how hard it is to have this kind of cross-disciplinary communication. And because of that, DPOs often rely on existing evaluations, let's say levels of security that have been set by other evaluators, or approval by third parties. And that also favors well-established technologies because it takes time to get these evaluations. So the consequence is that DPOs may be reluctant in making available data or signing some of these things, sharing data. I think we've heard this point already today as well. And it might hinder the introduction of new innovative technologies that are not yet well known, not widely known. The next theory is, well, we simply apply data protection measures, as Article 6 GDPR says, for example, appropriate safeguards, and all is fine. No need to worry. Well, in practice, protection always leads to trade-offs. The security leads to trade-offs. I've shown this triangle on the right-hand side. You can choose two: performance, reliability, security. It may lead to uneconomical data processing, performance problems because of the introduced additional security measures. And there might even be conflicts between security applications. So there's a compromise required here. It might be that accessibility, generality of the solutions, performance, etc., will suffer. For example, you might not be able to share all the data. You might not be able to share algorithms. You might not be able to have workflows where you reuse results of prior processing, and so on and so forth. And obviously, yes, it might happen that security measures completely prohibit applications or make it impossible to process in the way that you want to. The next one is, okay, we solve these security issues once for our platform, and then the scientific data management and stewardship for whole communities solved. So will be, once we implement these security measures, all is well. That's not the case in practice. This it always needs case-by-case evaluations. And one example is, I think we've heard this also today multiple times, that you need to set the purpose of processing. And simply changing the purpose of processing might influence the lawfulness of the processing. There's also the case of having different regulations per country, even per state in Germany, and so on and so forth. So it's impossible to solve it once and just have it for all use cases all over Europe. So that's what I call here no free lunch. There's no technical one-off solution to deal with all of these issues. And yeah, there will be bilateral contracts required between the involved parties. And then once we have these bilateral contracts, we can of course track them automatically. Well, unfortunately, that's not as easy either. There is a lack of machine readable and processable standards for contracts. This is a very hot research topic. You've probably heard smart contracts and so on. So at the moment, there's no, let's say, widespread, easy to use solution that we can apply in TVB-Cloud. And the implementation of such a mechanism is extremely complex in itself and matter of research, as I've said. Obviously, the development from scratch would be out of scope for TVB-Cloud itself. Well then, cloud providers, commercial cloud providers like Amazon, they should have all of this solved, right? We can just use them. Well, no, not at all. They face the same challenges, the gaps between law and technical implementations. There are no technical blueprints that they are just applying. And I mean, they do a lot of marketing, but that doesn't mean that they have everything solved. They actually also have commercial interest in data of all kinds. So it's questionable if you should trust them more. And there's also the cross-border challenges, very famously now the end of privacy shield. So you don't know where data is processed with a lot of commercial cloud providers. And only because it's commercial doesn't mean that they solved everything. Well, then let's use certified cloud providers because they should be sufficiently secure. In practice, that's unfortunately not the truth either, because certificates usually Well, there are different ones, but the most famous ones usually don't give you information on how secure the infrastructure itself is. They're most of the time rather about how security is measured and managed security processes. For example, the ISO standards, I've mentioned before, they're about managing security in repeated processes, always doing self-auditing, visiting your rules once per year, and so on and so forth. So solely making use of those providers doesn't guarantee data protection either. It might be required that the providers have these certificates, but not sufficient. What about scientific cloud providers then, like the European Open Science Cloud? They don't have a commercial background. Well, in fact, there's no difference at the moment in law between commercial or public providers, even the European Open Science Cloud. Most of the providers that are in European Open Science Cloud at the moment are not in general prepared for processing personal data. Some of them excluded in their terms of use. And very few of them offer certification. So what's the consequence for TVB-Cloud? The consequence is that we do a best effort security implementation to be as secure as possible, to implement as many security measures as possible. And we offer transparency. We document it transparently and implement these technical security measures following best practices and European or national standards. We also offer to, for example, to inspect premises through auditing. So this is to build trust from the users. And as said before, we're introducing these bilateral SLAs or contracts. Another theory, supercomputers are inherently secure enough for data processing because, I mean, they're supercomputers, very expensive, very special hardware. Well, unfortunately, that's not the truth either. Supercomputing centers, for example, from the PRAISE initiative, are not generally prepared for data processing personal data. So it's often excluded in terms of use, that you can't use personal processing, and they've simply not met this requirement very often until now. So there is a lot of initiative here, as was also presented by Professor Ritter, but it's not generally there yet. One of the challenges is that public supercomputers are shared resources. They are shared between a lot of different researchers at the same time. If we want to get a little bit technical, for example, the files on such supercomputers are usually stored in very high performance shared parallel file systems. And that means your data will basically reside next to the other researchers' data. So it's a multi-user shared resource. So exclusive resources would be possible, but obviously very expensive. So what's the consequence? As has been shown before, there is the possibility of using supercomputing, but it is mostly for anonymous data or adding a lot of additional security measures like the secure containers that have been shown before. And yes, the exclusive usage is possible, of course, if you have dedicated hardware. One other theory is that you can simply move computation to where the data resides instead. So instead of moving data, simply move the computations. That's a good idea in principle, but usually you don't have the necessary infrastructure where you need to do these computations. So there's, again, initiatives to change that, as has been shown. There are new infrastructures are being introduced at the clinic sites, for example, so you can do this. But at the moment, it's not available everywhere, and it also needs a lot of investments into hardware and also into personnel maintaining these resources. And the results of such computations that you do might still be personal data. As said before, it's not trivial to judge about that. So there's still limited further use of these result data. And it will be hard to share. The consequence being, this is not a generic solution for all use cases either. It might be implemented in TVB-Cloud for specific cases, but it's not the one-off solution for all challenges. So that's the last one we wanted to show. Obviously, there are more. What are our conclusions? Well, one of the conclusions is the abstract terms in GDPR really complicated practical implementation. One famous example is the appropriate in appropriate safeguards. I mean, what is appropriate? Interdisciplinary knowledge and collaboration is obligatory in this. And there are neither technical nor regulatory one-off solutions. So it's much more complex than that. And in TVB-Cloud, we're building up experience. We are trying out approaches. We are implementing different approaches. We're implementing frameworks, and we're also giving examples to realize these scenarios. So thank you very much.
Yeah, thank you, André, for your very interesting presentation and the challenging comparison between theory and practice.